Welcome back. Today we're starting a new unit on chemical bonding. In the last unit, we learned about the organization of the periodic table, and some of the big takeaways is that the elements in a family had the same number of valence electrons. And we studied the main 8 families on the periodic table. Family 1, the alkali metals. Family 2, the alkali earth metals. Family 3, the boron group. 4, carbon group. Moved over to the halogens, and then finally to the noble gases. So in this unit, okay, that base knowledge of where the valence electrons are is going to be very critical. One of the key things about nature is nature always seeks equilibrium. So when things are out of balance, it always seeks to put things back in balance. So things that are unstable, like the elements with less than 8 valence electrons, so pretty much everything except for the noble gases, will just naturally react until they become stable. This is why gasoline burns in a car engine. It'll burn until it becomes stable compounds, which is what we think of as the exhaust. So the elements combine together to form compounds, and like I just explained, nature seeks equilibrium, and the elements will react until they make stable compounds. The compounds are have completely different properties. So I put up this example here. We know from the last unit, sodium is an explosive alkali metals. We saw on that video they dropped the sodium in the water, and it immediately caught fire and started reacting. Chlorine is a highly reactive poisonous gas in its elemental form. Look on the periodic table, it's one of the nonmetals, and it tells us it's a gas. Usually, kids sometimes get confused. We see chlorine in chlorine bleach, and it's in a compound there, and when it releases, when it dissolves, it actually breaks into ions. There's a whole process we'll talk about, but it's actually in its elemental form, it's a gas. So we have these, explosive metal and a poisonous gas. They come together and they make a compound, table salt, NaCl, and it's harmless. So the table salt has completely different properties than the sodium metal and the chlorine gas. Why do they form compounds? Become more stable by achieving a full outer energy level of 8 electrons. So remember those noble gases, they had a full outer energy level, and with the exception of the first period, or the first energy level, helium that had 2, everything else has a full stable energy level when it's 8 electrons. And the elements that are joined together in compounds are more stable than they were as single elemental atoms. So for example, like the sodium is highly reactive, and so is the chlorine gas. Whereas table salt is not reactive. It's achieved that equilibrium, that stability, to where it's a stable compound, and you don't need to worry about like dropping the salt shaker and having an explosion. The noble gases are more stable because they have those full outer energy levels. Okay? And the elements combine to get a full outer energy level and be more like the noble gases, where they have that full outer energy level. It keeps them stable. 8 is the magic number. When you get to, if you take chemistry in high school or college, it's actually called an octet rule. So the prefix oct, like octagon, means like an octagon is 8-sided. An octopus has 8 legs. So oct means it's the Latin root for 8. Okay. Bonding always uses valence electrons. And that's why in the last unit we spent so much time fussing around with those Bohr models, and I had you make like 8 million Bohr models and ask you all about the valence electrons. What do they all have in common? Why do they all have the same properties? Because of the same number of valence electrons. Why are they in a family? Because of the same number of valence electrons. So that idea, like with the family 1, everything having 1 valence electron, and we said they were going to have similar properties, okay, they're going to bond in the same way because they have the same number of valence electrons. So something else like potassium that's in family 1, like sodium, okay, is also going to bond with sodium or with chlorine, and it also makes a form of salt. Okay, and the valence electrons, remember, are the ones on the outer energy level. Okay, there's two ways that they can combine. Okay, the first one atom loses an electron and one atom gains. And this means there is a transfer of electrons. So the one that loses gives one up to the one that gains. So it transfers its electron over. There can also be a sharing of the valence electrons. Okay, the prefix co means to share, like cooperate or cohabitate. So if you cohabitate, you share the habitat. If you cooperate, you share the operation, you share the work, whatever it is that you're doing. Each atom adds the electron to their outer energy level since they are sharing. So, if we share something, okay, during the time that we're sharing it, okay, it belongs to me and it belongs to you because we're sharing it. So, like, if we shared a pen, okay, I would use it and you would use it, and we would both consider it something that belongs to us that we're allowed to use. Okay, so it's called covalent bonding. And I put the prefix co here in red because the prefix co means to share. And so what are they sharing? Covalent means sharing valence electrons. So co means to share what? Valent electrons. Right, so earlier when we did Dalton's atomic theory in the first unit, we said it was a chemical bond is the force that holds atoms together through sharing or transferring electrons. And then specifically, there's two kinds of chemical bonds. One is an ionic bond when they're transferring electrons like this, when they gain or lose. And then there's a covalent bond when they share. So I want you to answer these questions on your own. And then next time when we come back, we'll take a look at this.